Revolutionize cellular health with our Plasma Med Bed technology. Hello. Thank you for giving me this opportunity to speak today. The title of my presentation is Plasma Med Bed, Next Generation ATP Accelerator. Today I will introduce the scientific background, main mechanisms, and initial clinical observations of this system. Plasma is the fourth substance. It is a state in which atoms are ionized, allowing electrons and ions to move freely. The Plasma Med Bed is designed as a multimodal bioenergetic system. It integrates four elements: plasma stimulation, oxygen enrichment, hydrogen gas, mild hyperbaric pressure. The main idea is to use several gentle signals at the same time, instead of one strong stimulus. Here are the main operating conditions. Plasma, 400 kilovolts, 4 units. Oxygen concentration, 28 to 40%. Hydrogen concentration, 3 to 5%. Pressure, 1.2 to 1.35 atmospheres. These parameters are intentionally kept within physiologically tolerable. One important point is low-dose ionizing radiation. Inside the Plasma Med Bed, measured gamma radiation levels are higher than natural background levels, but still within a low-dose range. Reported hormesis effects include activation of tumor suppressor genes such as p53, enhanced resistance to oxidative stress, neurostimulation and stress reduction, immune activation. This is based on the idea of radiation hormesis, which means that small amounts of stress can activate the body's protective and repair systems instead of causing harm. First, I would like to share a key idea. Very low levels of radiation are not always harmful. They can activate protective systems in the body and help cells maintain balance and normal function. Second, the body can adapt to mild radiation. This adaptation can reduce stress inside cells and make them more resistant to future challenges. So, low-dose radiation is not only a risk, it can also send helpful signals to the body. These are two cases showing red blood cells before and after hydrogen inhalation during PMB for 50 minutes. After treatment, the cells look more separated and uniform, suggesting better blood flow. We also examined oxidation processes. In a simple experiment using apples, the sample exposed to the Plasma Med Bed, 50 minutes, showed markedly delayed oxidation after 2 weeks. This visually demonstrates the electron-rich environment created by plasma exposure. This slide shows changes in tap water caused by the Plasma Med Bed. Over time, we see a clear increase in ionic activity and electrical conductivity, along with a rise in pH from about 7.3 to 8.6. These changes occur gradually and continuously, suggesting that PMB causes an active physical-chemical transformation of water rather than simple filtration. This slide summarizes how tap water changes after PMB exposure. We observe a clear increase in ionic activity, and the pH rises from 7.3 to 8.6, shifting the water toward mild alkalinity. These changes develop gradually over time, suggesting an active and continuous process, not simple filtration. This may indicate conditions that could influence biological responses. ATP is the primary energy currency of cells. Measuring ATP provides an objective indicator of cellular energy production. The purpose of this experiment was to evaluate whether exposure to the Plasma Med Bed is associated with changes in blood ATP concentration in healthy individuals. All measurements were performed by an independent third-party laboratory. Blood ATP concentration was measured using a luciferin-luciferase luminescence assay, a standard and widely accepted method. Light emission produced by the reaction is directly proportional to ATP concentration and was quantified using a plate reader and a calibration curve. This graph shows blood ATP concentration before and after exposure to the Plasma Med Bed. Before PMB exposure, ATP levels are relatively low and stable. During PMB use, ATP increases sharply, reaching about 3 times higher than baseline. After the session, ATP levels remain elevated, and this increase is still observed on day 2, day 3, and day 4, compared with the control group. Here are the key results. Immediately after PMB exposure, blood ATP increased by about 1.5 times. Because ATP in blood has a very short half-life, this suggests that ATP production during PMB exposure reached nearly 3 times the normal level. This indicates a strong, real-time activation of cellular energy production. Let me share real clinical cases by PMB with you. This is a case of a patient with spondylitis, and SLE-CRP and MMP3 are blood markers that show inflammation. When these values go down, it means inflammation is reduced and the condition of the tissues is improving. This is a rheumatoid arthritis case. CRP and MMP3 clearly decreased, showing that inflammation was effectively reduced. This slide shows a 40-year-old female patient of stage 4 gastric cancer. After chemotherapy and 7 PMB sessions, tumor markers decreased toward the normal range, and endoscopic images show clear tumor regression over time. This observation suggests a potential supportive effect, but further controlled studies are clearly needed. This slide shows a female patient in her 60s with stage 4 liver metastases from breast cancer. In combination with molecular-targeted chemotherapy and 50 PMB sessions, CT images demonstrate a clear reduction in tumor size over time. This slide shows the previous female patient with stage 4 lung metastases from breast cancer. In combination with molecular-targeted chemotherapy and 50 PMB sessions, CT images show a marked reduction in the number of lung tumors. This case suggests a possible supportive effect, but larger controlled studies are required. This slide presents a female in her 40s with stage 4 ovarian cancer and liver metastases. In combination with 3 chemotherapy agents and regular PMB use, CT images show a clear reduction in liver tumor size, along with a marked decrease in the tumor marker CEA-125. This case also suggests a potential supportive effect, but further controlled studies are required. In conclusion, the Plasma Med Bed integrates plasma, oxygen, hydrogen, and mild pressure to support cellular metabolism and immune regulation. Observed effects include increased ATP production, improved red blood cell condition, reduced oxidative stress, possible hormesis immune activation. While these findings are promising, further controlled clinical trials are essential. Closing remarks. Thank you for your attention. We welcome scientific dialogue, collaboration, and further critical discussion. We own both the basic and applied patents related to this plasma technology. At Expo 2025 Osaka, we presented next-generation plasma technology in the Future Life Village. Closing remarks. Thank you so much for your attention. We welcome scientific dialogue, future collaboration, and critical discussion.